Okay, so in this week's video, we're going to be looking at converting decimals into fractions. Now in class, we've already talked about how to convert fractions to decimals, and I just wanted to briefly recap this. So if we had a fraction, say 1/7, and we wanted to convert it to a decimal, the calculation we just need to do is 1 divided by 7. And you can use your calculator to do that rather than doing it in your head. And you should come out with 0.1429. I've rounded that to 4 decimal places. And you should find that when you convert a fraction to a decimal, the answer is either recurring or terminating. It shouldn't be an infinitely long number that doesn't recur, because otherwise that would be an irrational number, which, as we already know, can't be a fraction. So your answer should be one of these two forms, and you'll find that 1/7 is actually 0.142857, all recurring. So that's fractions to decimals. You just need to do some division. Now, decimals to fractions, we have two different cases, and I'm going to work with each case individually. So first of all, let's say case A, terminating decimals. Now, terminating decimals would be, for example, 0.6, 0.125, and just to keep it interesting, let's also go for 2.23. Now the trick to terminating decimals is to recognize that to get these numbers, for example to get 0.6, you would have to do 6 divided by 10. And that works for any single digit decimal. 0.4 is 4 divided by 10, 0.5 is 5 divided by 10. And of course you can cancel these fractions if I change my colour. 6 over 10, 3 goes into 6, as does 2. So 2 goes into 6 3 times, and 2 goes into 10 5 times. I look for the factors that these have in common, and I cancel. I'll do it more slowly here. I know that the prime factorization of 4 is 2 times 2. The prime factorization of 10 is 2 times 5, which means here I have 2 divided by 2, so I can cancel that. So here I have 3/5, 2/5, sorry, 3/5 for 0.6, 2/5 for 0.4. And I can do the same here. 5 is already prime, so I can leave that on its own. 10 is 2 times 5, which means I can cancel the 5, and I'm just left with a 1 on the top, and it shouldn't come as any surprise that 0.5 is converted to a half. So with a single digit, we just put this number in divided by 10. For 3 digits then, rather than dividing by 10, we would divide by 1,000. You take the number of digits after the decimal point, and you make those zeros after your 1 in the denominator. And of course, again, this can be cancelled. 125 over 1,000, well, that definitely has 25 in common. 25 goes into 125 5 times, and 25 goes into 1,000, goes into 104 times, so it must go into 1,040 times. And I can cancel this again, because 5 goes into itself once, and 5 goes into 48 times. So that's 1/8. And here I can do the same, even though I have a whole number at the beginning, I can just change my mixed number into an improper fraction later. So this, I'll put my arrow underneath as I run out of space, would be 2 and 23 over 100. that my number of places after the decimal point is my number of places after the 1 in my denominator. And I can convert this as 2 is 200 over 100, so it would be 223 over 100, because we had 200 over 100, which was our 2, plus 23 over 100, which was our fraction here. And I don't think I can cancel that any further, because 23 is a prime number, so that definitely won't cancel. And I can't see any cancelling here, so I can just leave it like that as my final answer. So for terminating decimals, divide the number after the decimal point by an appropriate multiple of 10. So by a multiple, or actually it's a power of 10. A power of 10. 10, 100, 1,000, depending on the number of places after the decimal point. Okay, next then we have our slightly more complicated section of recurring decimals. B. And this works actually in a very similar way. You just look at how much is recurring, and rather than dividing it by a power of 10, so 10, 100, 1,000, you divide it by something with all 9s in it. So if I had, for example, 0.3 recurring, I have one place after my decimal point that does recur, and that's my 3, and I divide it by the number of 9s I have after, or the number of places I have after my decimal point in 9. So here I have one place, and there I have a 9. And I can divide this. 3 goes into 3 once, 3 goes into 9 3 times, so that would be a third, which again shouldn't come as any surprise. If I had, however, 0.367 all recurring, then I have 367 on my numerator, divided by 1, 2, 3 9s underneath. 1, 2, 3 9s underneath. And if you do that on your calculator, 367 divided by 999, you should come out with 0.367, 367, 367, etc., etc. And it works the same for if we had 0.48, both recurring. That would then be 48 over 99. And I'll show you why this trick works. Well, if I had, let's take this one here, 0.48 recurring, and I multiply that by 10, then I would get, oh no, not 10, sorry, 100. I would get 48.48 recurring. Because I have infinitely many numbers after my decimal point, if I move 2 of them to being before the decimal point by multiplying by 100, then I will still have infinitely many 4s and 8s after my decimal point here. Then, taking this answer, if I take 0.48 recurring away from that, what do I get? Well, after the decimal point, every 8 and every 4 will line up. So after the decimal point, I will get lots and lots of zeros. Over on this side, I have 8 take 0, which is 8. 4 take this 0 here, which is 4. Which means that this is equivalent to 0.48 recurring times 99. Because I timesed it here by 100, and I took 1 off. So this is equivalent to 99 lots of 0.48 recurring. Which means that if 99 times 0.48 recurring is equal to 48, and I don't need to write in all the zeros after the decimal point, I can just rearrange this equation by dividing by 99 and saying, okay, 0.48 recurring is equal to 48 over 99. Done. So this trick works because of this. And if you want to have practice, you can show that it also works for 0.3 recurring and 0.367 recurring. As a final exercise then, because we've finished, we don't have any other types of decimals that can be made into fractions. Other decimals are irrational. I would like to combine what we've done so far. What if we had 0.8 and then 6 recurring? How would I turn that into a fraction of the form a over b? Because it is a recurring decimal, but it has this extra 8 at the beginning. You won't be asked to do this very often, but I just want to make sure that you can. Now what you should do with this, first of all, is break it down. Break it down into two parts. The first part should be a terminating decimal, and the second part should be a fully recurring decimal with no anomalies like the 8 at the front. So here, this is quite easy. What would I need to add in terms of a terminating decimal to a recurring decimal to create this number? Well, this number is the same as 0.2 plus 0.6 recurring. Because if I add this 0.2 to the first place of 0.6 recurring, I would get 0.8 in the first place, and then all of the other places would remain a 6. So we've broken it down. Then we convert each part into a fraction. So I know that 0.2 is 2/10. I know that 0.6 recurring is 6/9. And then I would do my addition. So I find my lowest common denominator of 90, and say I would need to times 10 by 9 to get 90, so 2 times 9 is 18. I need to times 9 by 10 to get 90, and 10 times 6 is 60. So I get 78 over 90, which I can cancel, because 2 goes into both of these. 2 goes into this, I think, 39 times, yeah? And 2 goes into 90 45 times. And actually 3 goes into both of these. 3 goes into 39 13 times, and 3 goes into 45 15 times. So I end up with 13/15. And I would always recommend checking your answer. It's a really good habit to get into. So on your calculator, do 13 divided by 15, and you'll get 0.8, then a recurring 6 that carries on forever. Hopefully the video's been helpful. You could try a couple more of these, invent some of them for yourselves, of having a bit at the beginning that's a bit different, and then a recurring decimal afterwards, and seeing if you can convert it into a fraction.